Hello and welcome to Fresh Thinking by Snowden Optiro. My name's Julian Aldridge. I'm the Regional Manager for the International Region for Snowden Optiro. Today I'm joined by Laurie Hassall, a Senior Geology Consultant with us at Snowden Optiro. Welcome, Laurie.
Thank you.
So Laurie's background is in production and exploration. He's worked for 12 years and has specific expertise in tin, tungsten and lithium. And he acts as a CP and QP for all three of those commodities. So you're joining us here for the first in our commodity series, which is a discussion on tungsten. So Laurie, what is tungsten and what are its applications?
Okay, so tungsten, it's actually one of the very rare metals in the periodic table, and it wasn't discovered until 1755, so quite late on in terms of metal discovery. And it was discovered by a Swedish mineralogist named A.F. Tungsten. And he actually named it tungsten in Swedish. And tungsten directly translates as tough stone. Now, tough stone is quite apt because of one of the material properties of tungsten, it being a very dense, very hard material. And in fact, it has one of the highest tensile strengths of any metal in the periodic table. Now, tungsten's other known name is wolfram. Now, wolfram is named after one of the minerals that hosts tungsten, which is wolframite. And the periodic table, tungsten is its chemical symbol is W. So wolfram, that's a Germanic name in origin, and it directly translates as wolfram or wolf's ram or wolf's foam, and that means devourer of tin in German. So, and this stems back to the days when it was very hard to separate tin from tungsten. And yes, and tungsten wasn't easily separated until the very late 19th century, when some magnetic separation was invented.
So I guess that leads on to my next question. What are the sort of the geological environments and deposit styles that are associated with tungsten?
Well, first of all, tungsten, the main ore-bearing minerals for tungsten are scheelite, which is a calcium-rich tungsten mineral, and the mineral series wolframite.
Yes.
So wolframite is a mineral series, so it's either iron-rich, which is ferberite, or manganese-rich, which is hubnerite. So they're the chief ore minerals that host tungsten. In terms of deposits, tungsten deposits are really only found associated with granitic intrusions, granitoid and geological environments.
Mm-hmm.
And tungsten is very much associated with some of the older granite intrusions within a batholith, and also often associated with muscovite-rich melts.
Right.
Tungsten has a special affinity with the mineral muscovite, and it can host a high content of tungsten within its lattice.
So are these always S-type granites? Are they from crustal melting?
Often they are, but not always. The deposit styles and the content and the ore mineral that hosts tungsten very much depends on the source melt, so whether it's S-type or A-type. Also, the fractionation series and also the emplacement depth of the granite itself.
Right. Okay. So, what sort of part of the world are tungsten deposits found?
Again, it depends on the deposit style. Depends on the deposit, but by and large, a lot of the tungsten deposits that are exploited are found in China. China produces around 80 to 85% of the world's tungsten, so it very much is a key player in terms of the tungsten market. And behind China, you also got Russia and Vietnam, also big producers of tungsten.
Yes.
And in terms of the Western world, there are large deposits of tungsten in the US, Canada, and also the UK as well.
Oh, right. Okay. How would one go about exploring for tungsten?
Yeah, so exploring for tungsten, I'll touch again on the sort of the geological environments. So, as mentioned, tungsten is very much associated with granites, and it's important to, if you're an exploration geologist, if you want to find a virgin tungsten deposit, it's very important to understand the granite terrains that you're exploring. It's all very well and good discovering a granite batholith, but
Yeah.
you've got to have the right conditions for tungsten deposits. Again, I'll touch on the fact that tungstens are associated with muscovite-rich melts. So understanding the geochemistry of granites within a batholith is very, very important.
Right.
As is age relationships as well. As mentioned, tungsten often is the very early, is associated with the very early granite melts and very early granite plutons.
Okay.
So understanding age relationships within a batholith is extremely important.
Right.
And once you've understood the geochemistry and the ages of the granite, then it's about doing the traditional, your traditional exploration.
Yeah. So sort of delineating geochemical anomalies,
Exactly.
trenching, drilling,
Yeah.
the usual process through which you get to developing projects.
Absolutely.
Are there any specific metallurgical or mineralogical considerations?
Yes, absolutely, Julian. So in terms of, I'll touch more on wolframite deposits. So it's very important to understand geometallurgy of wolframite deposits. It's important to understand what mineral you are dealing with. From a very early stage. Is it the iron-rich ferberite? Is it the manganese-rich hubnerite? And that's very important because if you've got more ferberite in your deposit, then you're going to process it very differently to a hubnerite-rich deposit. Ferberite, because it has that iron content, lends itself very well to magnetic separation.
It's magnetic.
Yeah, exactly. Magnetic.
Right.
The other important aspect to get a handle on from a very early stage is the alteration of the mineral as well. A fresh wolframite mineral will react very differently to an altered mineral when it comes to processing.
Right.
The main form of processing for wolframite deposits is gravity and then magnetic separation. So you have to understand the density of the ore mineral from a very early stage.
Yeah.
If you've got alteration of that wolframite mineral, it may be that iron is replacing tungsten. Now, tungsten is a lot denser than iron, and therefore, if your wolframite grain is altering to an iron-rich ferberite, then you're altering the density as well as the chemistry.
Right.
And wolframite will recover very differently when you are dealing with gravity separation processes.
So I presume these differences in alteration and chemistry mean that you've got to have a very detailed understanding of the mineralogy.
Absolutely, Julian, yes. And it's very important to, from an early stage in terms of a project, to understand what wolframite mineral you're dealing with, but also that alteration. So undertaking mineralogical work from a very early stage. So doing mineralogical work, whether that's optical or SEM, it's very important to fingerprint the mineral and whether there's any alteration present.
So leading on from that, how is tungsten typically mined?
It very much depends on the deposit style that tungsten is hosted within. So tungsten can be hosted within sheeted veins, stockworks, or skarn type deposits, or indeed vein and lode hosted deposits. Vein and lode hosted very much lend themselves to underground excavation. A great example of an underground tungsten mine is the Mittersill mine in Austria.
Yes.
So that's been going for nearly 50 years, and it's scheelite hosted and vein style mineralization. On the flip, stockwork and sheeted vein style mineralization lends itself very much to open pit style methods of excavation. So a great example of a sheeted vein hosted tungsten deposit is Hemerdon here in the UK, which is the second largest Crisco compliant mineral resource in the Western world.
Is that right?
It is, yeah.
Okay. Right here in the UK?
Right here in the UK, not far
Fantastic.
from where we're speaking.
Yes, and you've worked there, haven't you?
I have, yes, when it was in operation.
Okay.
Yeah.
Oh, very nice. So I guess, in terms of how tungsten is modelled, how you would create a geological model, a block model, and how you would go about estimating tungsten. Are there any sort of special considerations?
Well, yes, there are. One of the first things I would say with a tungsten deposit is that collecting the raw data is the most important. So ensuring that you've got the best quality raw data before you consider modelling and estimation is extremely important. And that's important for every commodity, as we know.
Yeah.
But there are some considerations I would suggest for tungsten and those that are dealing with tungsten deposits. And that is in terms of analysis. There are several different methods that you could choose for tungsten analysis, one of which is ICP, whether that's MS or AES. And there are also other different digestion methods as well for tungsten. And ICP as a method for assaying tungsten is robust. However, you've got to understand whether that digestion method is working well for the mineral that you are assaying.
Okay, so you can have a situation where you only end up with partial.
You could indeed. You could only have a partial digest,
right?
And if you don't catch that from a QAQC perspective and from an early stage, then you may not be getting that accurate tungsten assay.
So another good reason to have a strong handle on your geometallurgy.
Exactly
at this stage.
Understand that mineral, and you understand the material properties.
Right.
Another good, another analytical method, which I prefer for tungsten analyses, is XRF. In fact,
yes.
I think it gives a more robust analyses for tungsten. Yeah. So one of the things to look out for with XRF is that there are ion overlaps in terms of the energy peaks with tungsten. So tungsten and iron can share energy peaks. So it's important to understand that you are reading the X-ray signals correctly.
Is that a question of frequent calibration?
Exactly. Yeah.
Right.
And this leads on to my next point, which is understanding and developing your own calibration curves. Very important for tungsten. So developing your own standards is very important that are matrix matched from the deposit that you're working on.
Yeah.
It's very, very important. Developing that calibration curve with the laboratory that you are assaying at is very important. And to develop that calibration curve, it's all about sample numbers. So hundreds of samples to build that calibration curve.
Yes.
And that increases your confidence in the analyses ultimately.
Okay. Excellent. So, I mean, are there any special considerations during sort of modelling?
Yes. Well, one thing to be aware of is that often tungsten deposits are very nuggety, and that goes for scheelite deposits as well as watermite deposits as well. They tend to be very bunchy. The mineral is very nuggety, so if it's hosted in a quartz vein or in a sheeted vein, they tend to aggregate in mineral bunches.
Right.
So it's very important to understand that sort of short range mineralization continuity. And in fact, in terms of data collection, I prefer RC methods for tungsten deposits.
Right.
RC gives you that homogeneous sample,
much larger sample size.
Much larger sample size. Absolutely.
Yeah.
If you are drilling with diamond techniques, then it's important to collect a lot of field duplicates. When you are cutting the core in half, it's important to collect those duplicates, which are the corresponding opposing half of the core.
Yes.
And that'll give you that confidence in terms of the nugget effect that tungsten may be having.
Yeah.
And understanding, what that might be, and it gives you that confidence using diamond samples in your resource.
I mean, the nugget effect is always a complex issue, isn't it? I mean, you've got, from one end of the spectrum, you've got something incredibly homogeneous like phosphates or bauxites, and then all the way up to very nuggety gold deposits and diamonds and things. So, is your view on tungsten that it sits?
Yeah,
towards that.
I would suggest it's sitting towards the gold end of the spectrum for sure.
Right. Okay. So it's that nuggety.
It is.
Yeah,
that's right. Yeah.
So I presume that the best way of dealing with that is sampling very, very frequently and drilling on a very close density.
Absolutely. Yeah. So understanding that short range continuity, understanding the best sample and drill spacing is extremely important. And also the correct sort of sample, raw sample length as well.
Right. Oh, fantastic. Fantastic. So that draws this podcast to a close. Laurie Hassall, thank you very much for joining me on Fresh Thinking and participating in a discussion about tungsten.
Thank you. Thanks, Julian.
So if you'd like to listen to more of our Fresh Thinking by Snowden Optiro podcasts, you can find them for free on our website, Spotify, Apple Podcasts, Libsyn, Google Podcast, YouTube, and most other podcast platforms. Don't forget to smash that like button and subscribe.